Hello, I'm Travis Newton. My topic is remote sensing in Rarotonga Islands, part of Oceania. Island lies northeast of New Zealand and south of Hawaii. I'm going here for an internship with Global Trek next month to map tourism for a publication book. And I'm specifically wanting to know what are the best techniques to capture change detection in reef and coastal lines. That'll end up displacing 11.4 million people within Oceania due to sea rise caused by global warming. Here is my source data at the top. Most all downloaded from USGS. I reprojected it to the UTM Zone 4S. Satellite or aerial imaging for Oceania is not profitable, so there's not a lot of it out there. And so it comes with disadvantages. You know, you have cloud coverage over tropical islands. You have tidal changes 4 per day. You have tidal change seasons due to moon activity, sun activity. Multi-resolutions, so we have 30 on the Landsat, 10 on the Sentinel, and 1 on the orb view. And then so trying to distinguish between like river streams, small little huts, going from these different size pixels really throws off your data. So the good things about mapping though is you always have lots of vegetation. That vegetation is going to remain the same throughout your images, and the trees are mostly distinguishable, as you'll see. So to the left I have my methodology techniques, just some of the tools I used, the reasons I was using them. Most of it was the masking I tried to do. My goal was to create a Landsat 7 mask, and then because it was the oldest data, that I could then overlay with Landsat 8 and then overlay with Landsat or Sentinel, block out that clouded area from that first image and only analyze what we could see. However, it didn't work. I couldn't mosaic it, and I couldn't overlay it correctly to block it out. I could just like look at it. So it'll be something I'll continue to work on. To the right is my INLCC index, which is the Island Nation Land Cover Classification Index. That's it's official. I claimed it. And those are the different ideas. Indigenous versus non-indigenous are pretty distinguishable because like you have clumps of cauliflower trees versus like clumps of evergreen trees is how I like to compare them. And then your upland pastures are distinguishable by color versus lowland agriculture. Down in the bottom left I have sensor characteristics, and so for the reef study, you know, if we were not to look at any spectral or spatial enhancements, those are the best resolutions I found to see different changes. In the OBI that I did, the higher classification technique was used. It wasn't profitable as far as a good quality change detection. Here is the tidal data for the best classification method, which was the supervised on the top left. On the bottom left, you can see the attribute matrix for the different techniques I used, which were Landsat 8 supervised, the Landsat 8 OBI, Landsat 8 orb view hybrid, and Landsat 7 supervised. Now this hybrid, what I end up doing is digitizing 15 different samples from the orb view 1 meter, then overlaid those shape files, traced them using the land classification methods on Landsat 8, and came out with an output that was far too skewed, because when you move from 1 meter resolution to 30 meters, you encompass pixels that shouldn't have happened. Doing these training samples or doing the accuracy assessment, I ended up using 400 points because like we didn't use cloud cover or didn't use cloud shadows, didn't use rivers and streams for Landsat 8 basic supervised. Here is a basic flow matrix that on the right hand side that has followed the class pretty much from week 2 to week 13. Some of the other images I was coming up with or changed ideas were the NVDI. I want to show, okay, this is where vegetation stops. This is where the coastline begins. It doesn't work too well because it kind of blends in with the lagoon. The band floats were kind of nice, kind of made that pop out a little bit. But then overall, the best method was the high pass with the wavelength change symbology. And later I will go and digitize this against the UAV image I collect this summer. And then to answer our overall question, we found 2 good techniques, which were that supervised classification and the high pass method with the change symbology. Overall classification of 80% with a CAP score of 72. Given the 30-meter resolution at such a small area, I think is acceptable. We also know that we need a higher resolution to make the distinguishable changes of these small island characteristics. No green, no life. We also have no reef, no life, because if people can't fish, then they're going to go and cut down trees, and next thing you know, it'll be Easter Island all over again. Solutions I have for this are, the UN starts a program where they get to fly UAV on all of the Oceania islands to every 10 years and make these change differences known to the world, and have a plan for relocating these people later on. What I'll do this summer is collect GPS sampling, river streams, georeference targets of the reefs, tree clusters, those different types of tree clusters, and just impervious versus non-impervious surfaces. And I will reduce the overall box extent of so I can, when doing the accuracy assessments, I can cut out all the ocean areas and continue this work in GIS 582. Overall, any questions, and I will leave you guys with what I attempted to do with the mask going from Landsat 7 at the top to Landsat 8 in hopes of trying to only make a change difference between those two. It didn't work though. Thanks.